Hello, everybody, and welcome to today's class. Today, we are going to look at electrochemistry, and it is one of the required parts of JUPEB syllabus. And this is divided into different series. So it means this video as well will be divided into various sections, and the section, all of them together, will cover what we have under electrochemistry. So let's look at the learning objectives of today's class. After today's class, you should be able to define electrolysis, electrolyte, electrode, anode, and cathode. You should be able to understand and should be able to explain the basic principle of electrolysis and distinguish between molten and aqueous electrolyte. And you should be able to state and apply Faraday's first law of electrolysis to calculate mass deposited or gas liberated. And finally, you should be able to state and apply Faraday's second law of electrolysis to compare the masses of substances liberated by the same quantity of electricity. So let's get started. So let's start with what electrolysis is. I believe you have seen how pure metals are made, or maybe you've heard how pure metals are made from their ores, or how we coat one metal with another metal. So the process of coating a metal with another metal, or how pure metals are extracted from their ore, involve electrolysis. So what is electrolysis actually? If you ask you to define electrolysis, it is the process of using electrical energy to drive a non-spontaneous chemical reaction. So when we say a non-spontaneous chemical reaction, it means a reaction that cannot normally happen on their own. So we have to force them to happen. So we can use electrolysis to force some reactions to happen. So what about electrolytes? An electrolyte is a substance that conducts electricity in molten or aqueous solution, and it gets decomposed during electrolysis. So an electrolyte contains free mobile ions. So as you see from the definition of electrolyte, it means it can be in molten form or in aqueous solution. And that electrolyte, whenever electrolysis happens, electrolyte get decomposed during the process. And whenever it decomposes, it forms free moving ions. So this one will bring us to another term that surrounds electrolysis. We talk about electrolysis, we defined electrolyte, and now we're looking at electrodes. Electrodes are just conductors. They can be metals, they can be graphite. Remember, graphite is a form of carbon that conducts electricity. So it means it can be used as an electrode. So conductors um, allows that allow electricity to enter into the electrolyte and also allow electricity or electric current to go out of the electrolyte. So those are electrodes. I will give you structure. I will give you a diagram that incorporates all of them: electrolyte, electrodes. So we have two more terms to look at. That is, electrodes can be divided into two parts, or it can be divided into two types. So the two types of electrodes are anode. Anode are positive electrodes, and cathode are negative electrodes. Anodes at anode, oxidation occurs. When we say oxidation, remember, oxidation is loss of electron. So electron leaves the electrolyte through the anode, and cathode is a negative electrode where reduction occurs. Remember, reduction is gain of electron. So it means electrons get into the electrolyte through the cathode. So why is electrolysis so important? Maybe somebody asked you that question. For electricity to flow through a substance, there must be charge carriers. There should be something that will carry electrical charges from one part or from one area to another. So in metals, charge carriers are free electrons. If you remember metallic bonding, remember it is a bond between a metal cations and its free mobile electrons. So what carries electrical charges, or what carries electricity, or what make metal a good conductor of electricity is the free moving electrons. So, but in electrolysis, the charge carriers are ions. In electrolysis, um, what carries electrical charge from one place to another are not, or is not, electrons. Rather, it is ions. So I think they ask this question in exam sometimes. So the ions are the charge carriers in electrolysis. So when these ions are free to move, either in a molten state or in dissolved solvent like water. So what I mean by this is when you have a solid, for example, solid sodium chloride can conduct electricity. Cannot conduct electricity because the ions, that is the sodium ions and chloride ion, they are not free to move. So they are only set free to move whenever you melt the sodium chloride or you dissolve the sodium chloride in water. So when you melt sodium chloride, you allow the ions to move around. So when they're allowed to move around, they can carry electrical charges from one place to another. At the same time, when you dissolve sodium chloride in water, it means sodium ions and chloride ions are allowed to move around. And when they can move around, they can carry electrical current from one place to another. That is why we call them charge carriers. So whenever electrical currents are carried from one place to another, chemical reaction can happen. So let's look at this diagram. The diagram summarizes everything we said about electrolysis, electrolytes, electrodes, anode, and cathode. So here, this diagram represents electrolysis. And of course, we have electrolytes now, which is this gray substances. This gray substance is the electrolyte. I remember the definition of electrolyte. And then we have our anode. So this is an electrode, and this is another electrode. And remember, we said there are two types of electrodes. We have anode, which is a positive electrode, and we have cathode, which is a negative electrode. So these are the two electrodes. And then we have this that was not mentioned in the definition. This is the supply of the electric current. It can be battery. Usually it is battery. So this is the what supplies electric current into the circuit that allows the electrons and ions to move around in circuit. So this is the positive charge side of the battery, and it is the negative side of the battery. So what must always come to your mind is that the negative side of the battery is rich in electrons. So you have more electrons at the negative side of the battery, more than what you have at the positive side of the battery. So if battery want to supply electrons or electric current into the circuit, that is into the electrolyte, it will come out from the negative side of the battery. So the arrow would be like this. So go to the cathode. Remember, we said at the cathode reduction takes place. And if you remember reduction is the gain of electrons. So it means electron that is coming from the negative side of the battery will be gained at the cathode. So that is why cathode is also negatively charged. Now in the electrolyte, what carries electric current is no longer electron. It's going to be ions now. So the ions in the electrolyte will now carry the electrical current that is coming from the anode So carry it down to the anode. So where oxidation will occur at the anode. So at the anode, oxidation occur, that is, there's going to be loss of electron at the anode. So the arrow from the anode will go up this way and then this way. That is how the circuit goes. So oxidation is gain of electron. So electron, that is electrical charge that is carried by the ions in the electrolyte will be, oxidation is loss of electron. So electron will be lost at the anode, and the electron loss at the anode will go from the solution out. You can see the arrow go out of the solution and then to the battery again. It gets released from the battery again, gain at the cathode, and that is how the circuit goes. So let's look at an example of electrolysis. We're not going to go deep into the explanation right now, just for you to know, to have it in behind your mind, an example of electrolysis. So we're going to look at the electrolysis of sodium chloride. Remember, sodium chloride is the salts that we eat. Remember, it is the table salt. So sodium chloride contains sodium and chlorine, but in form of a compound. So if we would need sodium, we want to get sodium from sodium chloride, or we want to get chlorine gas from sodium chloride. It is difficult to do that without passing through or without using electrolysis. So sodium is a very reactive metal, and it does not separate. You cannot just separate it easily from chlorine. It cannot do that on its own. So if you want to get sodium chloride from, if you want to get sodium or chlorine from sodium chloride, we just melt sodium chloride. So when we melt sodium chloride, remember, it becomes an electrolyte. Remember, an electrolyte conducts electricity either when it is in molten form or when we dissolve it in solvent, just like water. So in this case, we melt sodium chloride to become an electrolyte. And then when we pass electric current into it, so what will happen is that electric current will force the sodium ion to gain electrons, and then it becomes sodium metal. Remember, gaining of electron is reduction. So when it becomes sodium metal, something will happen to the chloride ions as well. The chloride ion, they will lose electron, and then when they lose electron, they will become chlorine gas. So we have formed chlorine gas and sodium metal from sodium chloride, a table salt, using the process called electrolysis.